Hello friends, welcome to our channel Mechanical Motivator. In this video, we will be seeing problems on vibration isolation and force transmissibility. So we will be seeing a machine body here. Actually, there are two springs and a damper is fixed. We need to understand a basic thing. That is, when we are operating on a machine, there will be a lot of vibrations, and these vibrations may have a chance of transmitting to the earth. So in order to avoid that, we will be fixing a foundation between the ground surface and the machine, and this is called as foundation in order to arrest the vibration. Also, we will be also having a damper also in order to reduce the vibration. So here we will be seeing two concepts, that is a transmissibility ratio and vibration isolation. We will be seeing here. Transmissibility factor or isolation factor is nothing but it's a ratio of how much force transmitted to the force applied. So force transmitted is due to the vibration, the force will be transmitted to the foundation, and this force applied is will be applying a force on the machine, and it will be denoting that. So there will be two force playing a major role. One will be the spring force, and another will be damping force. Spring force will be restoring the force, and damping force will be reducing the vibration, and also with the help of a friction. So what happens here is we will be having two different forces, as I said earlier, and we will be dealing with a few formulas. So once if we know 2 to 3 formulas, we can directly apply in the problem for solving it. So here is the formula for force transmitted, and we will also be having a few more formulas. That is for this is called as epsilon. The epsilon will be force transmitted to force applied. So epsilon, there will be a formula here, and if in question, if they are giving if they are asking us to ignore damping means, I mean neglect damping means, then C will be 0. So then the formula will changes to as it is shown here. So there will be two values. One that epsilon, I mean the force transmissibility will be negative if we use this formula. If we want a positive value means, we will be using this formula. Mostly we will be using this formula only. We will be having a positive value. And in question, if they are giving a resonance, that is omega will be equal to omega n. That is circular frequency of the body will be equal to the natural frequency of the applied force. So if these two are equal means, then it will be a resonance condition, and we will be having a separate formula. So in this chapter, we will be having 4 to 5 formulas, and it will be very basic, and it's very easy to solve also. And we will be saying 2 to 3 problems now. A machine has a mass 100 kg, so M will be 100 kg, and unbalanced reciprocating mass will be 2 kg, so MR will be 2 kg, which move through a vertical slope of 80 mm. So stroke length will be 80 mm, so L will be 80 mm, so convert into meter. It's a simple harmonic motion. The machine is moved around 4 springs, so number of springs will be 4, symmetrically arranged in the center of mass in such a way that the machine has 1 degree of freedom and can undergo vertical displacement only. And they have clearly said that we need to declare damping. So C will be equal to 0. So first, in this question, we will be divided into two halves. So first off, what we're going to do is we will be calculating the combined stiffness of the spring. See, we need to calculate the combined stiffness of the spring in order that force transmitted to the foundation is 1/25 of the applied force. So they have clearly given that force transmitted will be equal to 1/25 of the applied force when the speed of rotation of the machine crankshaft is 1000 rpm. So they have given the n value. So the speed value they have given us 1000 rpm. When the machine is actually supported on the spring, it is found that when the machine is actually supported on the spring, it is found that the damping reduces the amplitude of successive free vibration by 25%. So they are what they are coming to what they are trying to tell us, if it's a successive free vibration, that is the amplitude of successive free vibration means, successive means then x1 x2, so it will be reduced by 25%. So automatically we'll be having 75%, right? So x2 will be equal to 0.75 x1. So x1 by x2 will be having a ratio of 1/0.75. So this condition actually we got from here. So try to understand. So it is reduced by 25%. So remaining 75% will be there. Successive amplitude means x1 and x2. So x2 will be 75% of initial value. So we are writing as x1 by x2 is equal to 1/0.75. So we need to find force transmitted to the foundation. So initially we'll be determining the combined stiffness, and second we'll be determining force transmitted, and third we'll be determining amplitude of force vibration of the machine at resonance condition. So next thing what we're going to determine is we need to determine amplitude at resonance condition, and also we need to determine the fourth one, we need to determine the force transmitted at 800 rpm. So actually we need to determine four things. First one will be determining combined stiffness, and second will be force transmitted, and third is the x max amplitude at resonance condition, and fourth condition is, actually they haven't written here, fourth condition is force transmitted at 800 rpm. So first we need to determine stiffness, right? So damping, ignoring damping means C will be equal to 0. So epsilon is equal to, this is the formula we already saw here. Actually we saw this formula here, right? So epsilon is equal to 1 by omega n whole square minus 1. So we have taken the formula, and we know the value of epsilon. So epsilon is nothing but force transmitted to force applied force. So just cross multiply this, just bring this force, applied force downwards. So ft by f is equal to 1 by 25 is equal to epsilon, which is nothing but transmissibility ratio. So just substitute epsilon is equal to 1 by 25. So among this we can, actually we don't know the value of omega and omega n, right? But omega we can easily calculate. Omega will be 2 pi n by 60. So 2 pi n is 1000 rpm. So n they have given is 1000 rpm. So we can get the value for omega. So while substituting the epsilon value, we'll be getting an equation like this: omega by omega n whole square will be equal to 26. So omega we can calculate with the help of n, and omega n is something but root of s by m. So just substitute this in equation 2. So root of s by m means, so listen here. So omega by omega n, right? So omega is 104.72, right, as it is, and omega n is root of s by m. So right as it is, root of s by m whole square is equal to 26. So among this, we actually we won't be knowing mass value. We know, we don't know only the stiffness value. So s value is around, s value is the only unknown. So just keep the s value alone on the left hand side and take everything to the right hand side and reduce the equation, and you will easily calculate the value of stiffness. So next we need to determine force transmitted. So x1 by x2 is equal to 1.33. Actually how we got means x1 by x2 is 1 by 0.75, right? So once we calculate means we'll be getting 1.33. So this is a logarithmic decrement value. So ln of x1 by x2 is equal to 2 pi eta root of 1 minus eta square. So we got this from logarithmic decrement. So x1 by x2 ratio we know 1.33. Actually why are we doing like this means we need to determine the value of eta. Once you reduce everything, only eta is the unknown, and you can determine the value of eta. Eta will be 0.045. What for we are doing is actually the force transmitted, that is epsilon will be equal to force transmitted by force we can easily calculate. And if you want to calculate epsilon, we need the value of eta. For determining this eta, we are doing these steps. So just reduce the equation, and you will be getting the eta value as 0.045. So next one will be critical damping. So why we are determining critical damping means we need to know the eta value. For that we have got the eta value. For determining C value we are doing like this. So CC is the critical damping coefficient. So 2m omega n. Omega n is root of s by m. Stiffness we know, mass we know. So just substitute all the values. We'll be getting a critical damping as omega n we got as 20.53. So just substitute the omega n value, and you will be getting the critical damping coefficient. So eta is equal to C by Cc. So we can easily determine the damping coefficient also. So epsilon will be, this is the formula at resonance condition. Actually they have given that we need to calculate force transmitted at resonance condition, right? So at resonance condition, this is the formula. So eta value, epsilon value we will be getting 11.156. Eta value we just got from previously 0.045. So eta is equal to ft by f. So we know the force, right? Centrifugal force formula is mr omega n square r. So r means that stroke length, half of the stroke length. So just substitute all the values, and you can easily get the value of force transmitted. So just substitute here, and you can just substitute the applied force, so that you know the applied force and you know the epsilon value. You can easily get the force transmitted. So force transmitted is equal to epsilon into force applied. So you will be getting a value of 376.4 Newton. Now third condition is we need to determine the amplitude at resonance condition. So x max is equal to f by c omega n. F value we know, c value we know, omega n value we know. So just substitute all the values and you'll be getting x max value. And fourth condition is we need to determine the force transmitted at 800 rpm. So what we're going to do is force transmitted is equal to x max root of, this is the formula. So actually now in fourth condition we cannot use the rpm as 1000 because in this particularly they have given us 800 rpm. So use that 800 and determine the omega value and substitute the omega value. So now what we're going to do is we are going to find the x max value because we need to substitute here, right? So x max formula is this. So just determine the x max value. So force we know 33 point, we just now got, right? Force value we got 33.74. So just substitute the force value and substitute all the values and you will be getting an x max. So once you got the x max, mean just substitute this x max in this ft formula in order to determine the force transmitted. So x max, in order to determine x max only we are doing these steps, and once you found means substitute here. And stiffness you know, c value, omega value, all the values we know, so we can easily get the force value. So next sum is a vibrating system having a mass of 2 kg. So mass 2 kg suspended by a spring of stiffness 1200 1300 Newton per meter, and it is put to a harmonic excitation of 10 Newton. So force will be 10 Newton. Assuming viscous damping. Viscous damping means either a liquid or oil will be used. Determine the resonant frequency. That is, we need to determine the frequency, right? Frequency, phase angle phi we need to determine, phase angle at resonance, and amplitude. So x max, so x max amplitude at resonance, so x max at resonance, and damped frequency fd. So these four things we need to determine, and c value they have given us 40 Newton per meter per second. So it's very much clear to write from the question the given data and the what all we need to find. So first thing is frequency. So frequency is omega n by 2 pi, right? So omega n formula is root of s by m. We know the value of stiffness and we know the value of mass. So just substitute. So mass is 2 kg, stiffness is 1300. So we can easily get the value of omega n. So frequency means omega n by 2 pi. So substitute 25.49 divided by 2 pi means you will be getting frequency value. Second thing, we need to determine the phase angle at resonance condition. At resonance means omega is equal to omega n, and phase angle formula is just substitute all the values and you will be getting a phase angle as 89 degree 59 minutes. Third thing, we need to determine amplitude at resonance condition. So we know, right, x max is equal to f by c omega n. So substitute all the value. Force value we know. Force value they have given 10 Newton. C value we know. C value is 40. And omega n just know we got it. So just substitute and you will be getting an x max value. So fourth thing is damped frequency. So damped frequency means fd is equal to omega d by 2 pi. So this is the formula. If you want to know the omega d value, damped frequency means omega d is equal to omega n root of 1 minus eta square. So we need to determine the eta, right? So eta is nothing but c by cc. So cc we can easily get 2m omega n. Omega n we know, so cc we can easily calculate, and c value we know. Since we know the c value and cc value, eta can be easily calculated. So eta we'll be getting a value of 0.39. So just substitute the eta value in omega d. Omega d is equal to omega n root of 1 minus eta square. So omega n and eta we know, so we'll be getting omega d value. So once omega d is known means it's easy to determine the damped frequency, right? Damped frequency is equal to omega d by 2 pi. So substitute the value and determine the damped frequency. So we have a basic two problems. In case if you are having any doubt means, then type in the comment section, or else if you want me to take any other, talk on any other subject or a particular topic means, type in the comment section. Please do subscribe to my channel Mechanical Motivator and press the bell icon. Then only we will be getting all the videos which I upload. Thanks for watching this video. Have a great day.